Agent 42, Robert Weekway, has broken into the evil Red Cloud organization to steal back the diamonds of Gaia that they plan on using to amplify the power of the Destructo Ray. Upon breaking into the room housing the diamond, Agent 42 realized he is now trapped in the inverted right pyramid-shaped room that was quickly filling with water at a rate of 20 feet cubed per second. The height of the room was 35 feet, while one side of the room was 18 feet wide. How quickly is the water level rising when a room is completely filled? Okay, so this equation is not that difficult. It's convoluted, yes, but not difficult. So, in order to find the rate of how the water is filling at max height, first we must do this based off of the volume. So the volume of a square pyramid is 1/3 base squared times height. In this case, the base is our side length. So then that would change the volume equation to volume equals 1/3 s for side squared times height. Okay. Now we need to find what this s represents. In this case, we know that side height, the side and the height is equal to 18, because our side length is 18, over the height, which is 35. So then we can just use simple algebra to figure this out. Just multiply the h over here, which will equal the side length equals 18 over 35 h. Thus changing our equation again to volume equals 1/3 parentheses 18 30 over 35 times h, square that, times h. Okay, so now we have our volume equation, which we will use to find our rate. Okay, so before we can calculate our rate, first we need to fully simplify our volume equation. To do this, we need to use order of operations. So that means we need to square what's inside of our parentheses first. By squaring our 18 over 35 and h, we will get 324 over 1,225, and then h will become an h squared. Now we should just put that back into parentheses, so then we can just add our 1/3 and our h, and equals volume. Okay, now we need to simplify this again by applying the 1/3 to this fraction right here, and the h here so we're just combining like terms. So then this 324 over 1,225 will become 108 over 1,225 times h to the third, And thus we have our simplified volume fully. This is the final version. We're done with the volume now. Now we can go on to the next step. This step is honestly the most complicated one, in which we take the derivative. Okay, so before we can take a derivative, first we need to understand what a derivative is. A derivative is basically telling you what you're taking a derivative of at a certain point in relation to something else. Basically meaning v or volume, a derivative of volume in relation to time would be represented as dv over dt. The change dv basically means the change in volume in relation to dt, the change in time. D basically means change. D means change. Okay, so in this case, we're trying to find. Let me just erase this in a way. So in this case, we take the derivative of v, change that to dv over dt, because we're trying to find the change in water at a certain time, the rate of water at a certain time. So we take derivative of the v equals dt over dt. Then we can take the derivative of our original equation, which is 108 over 1,225 h to the third. So to take derivative of this, we need to first take the cubed, multiply the 3 over here, and that 3 term is then minused by 1. So that means the derivative is 3 times 108 over 1,225 h squared. But then also, seeing that we're taking the derivative of this, the rates we're trying to find is now in this equation. The rate we're trying to find is a change in height at a certain time, because it's change in height of the water. So that's dh over dt. So our end goal is to find this. Now, the equation actually gave us the change in volume over change in time. That is our 20 feet per second, which we just do 20 feet per second. This is equal. So then it's just 20 times 3 equals times 3, 108 over 1,225 times h squared times dh over dt. Okay. And now we just apply the 3 times the 108 over 1,225, which equals 324 over 1,025 h squared dh dt. I apologize for my handwriting. It is atrocious. Just shameful. Just write that 20. Okay. So now we need to go to the next step, which is just taking the 20 and taking the 20 and just dividing it by this, just putting this over here, just leaving the h squared here. So then let's just get rid of all this so we have space. Can I change that? Nope. Okay. Just erase all of this. Just erase. No, I'm gonna skip this. There we go. Magic. Fix 3. Not fixing it. You're not fixing it. You're just making it worse. Just making it worse. Good enough. So then we just work up here. So the 20 divided by the 324 over 1,205 would equal 6,125 over 81, but then we just carry over the h squared. H squared just carries over here. Just put h squared right here. That'll be useful later. And okay, that's swastika. No, just now. Bad times. Okay. So now we have our derivative that equals our rate. So there we go. Now we have the equation for our rate. Now we just need to apply the height we need. Replace that for the height in the equation, and we can then find the height that we need, our actual rate. Okay, so now we just need to calculate our height at our rate for when the pyramid is completely filled at a height of 35 feet. So, to represent this, we'll be finding the change in height in relation to the change in time at height of 35. Now, earlier we found out our basic equation, which was 6,125 over 81 times height squared. That height is 35 squared. Squared 2 there. Yeah, good enough. Okay. Which would equal 5 over 81, and our unit of measure would be feet cubed over seconds. So here's our rate. Water is gushing in at a rate of 5 over 81 when the tub is completely filled. Not that hard. You thought we were done. But we were not. Because Robert managed to escape the trap with the diamond. However, he found himself in another one. This time he was trapped in a right side up pyramid, in which the water from the other pyramid is pouring into this one, at the same rate in which that pyramid was full. So basically just a continuation of our last problem. So Robert is 6 feet tall and standing at the bottom of this new pyramid. How long does he have before he drowns? It's cruel, cruel fate, Robert. How do you manage to get yourself in that? Okay, let's figure out how much time he has left to live. Let's figure out how much time he has left to live. Okay, so this equation is not that difficult. It's basically just a continuation of our last one. So, in this case, we are using a radius of 9 for our original, because last time we were just referring to the base as a whole as 18, but half of that is 9, so it's giving us the radius. So radius of 9, the height remains the same at 35, equals the new height that we're referring to is 6, because Robert's 6 feet tall. But we don't know what this new radius is. We don't know what this new radius is. It's a mystery. Well, that's easy. We can figure that out through cross multiplication. Just multiply the 9 with a 6. It gives us this terrible 5. It gives us 54. Carry over 35 over 35 equals R. But why do we just do that? Well, in order to find how long it takes for the water to rise to 6 feet at a rate of 5 over 81. That's 81 feet per second. We first need to figure out how much water is in that 6 feet. To do that, we just need to take this volume, which we know that to be 1/3 pi r squared. We found r, so that's 54 over 35 squared times height, and we know that height is 6 times height. So then just figuring this out, and the volume would be 14.957 feet cubed. And there's our volume. Now, that's literally the hardest step in this whole process. So now we can take our rate and our volume to find our time. Okay, so we have our volume of 14.957 and our rate of 5 over 81. Yeah, this is feet cubed. This is feet cubed over seconds. Also, earlier, I'm not sure if I remember to put that cubed next to this feet earlier. That's supposed to be there. I apologize if I didn't put it there. So, to find our time is really simple. All we need to do is just do 14.957 divided by 5 over 81. Easy, because basically you're just doing 5 cubed feet. I'm confusing myself. Feet cubed seconds. Feet cancel out. You're left with seconds. Thus, you'll have 151.439 seconds. Then if you choose to divide that, then if you want to simplify this a little bit, all you can do is just divide this by 60, because there's 60 seconds in a minute, and you'll find that Robert has 2 minutes and 52 seconds. We'll just put a 4 there because bring out to 3 digits. He has basically 2 minutes left to live before he drowns. So we better figure out a quick way to get out of there. Good luck with that. Good luck with that, Robert. 2 minutes left to live.